Hello and welcome to this video series on Spring Boot tutorial. This video is part 1 of section 5, deploying Spring Boot applications. We will be deploying our Spring Boot applications on a container, that is Docker. So first let's understand what is Docker and its architecture. Now basically Docker is nothing but a platform where all the developers and system administrators are able to develop, deploy, and run applications with containers. Don't worry, hold on to the terminology containers we will be covering in the upcoming slides. So basically, developers struggle with deployment of their code which they have created on environment. Say for example, today I created my application on the development environment that consists of Windows operating system, maybe using a Tomcat server having dependencies on some DLLs or libraries or binary file. Tomorrow I need to take this development environment and deploy it on the production environment, which may be of Linux, Unix, or it may be Mac or any other platform, any other server, databases, or whatever binaries and libraries that particular platform supports. Now, here there was a gap in the development and the production environment where the developers had to take care of whenever there is a switch in the environment. So basically, if we see in the SDLC, that is design, development, deployment, and testing, Docker fits in the section that is deployment. So it basically helps the deployment of your application in an environment wherein it is not dependent on the platform or the libraries used for that particular platform. It also helps separation of concerns and at the same time let developers develop an application without worrying about the development environment and the production environment and the differences in the architecture of the same. Now to understand the Docker, let's see where the Docker workflow fits in and how it actually works. Now as a developer, you will be creating an application. Maybe it's a Python application, a Spring application, a Ruby application, a PHP application, whatever type of an application it is. You want to be able to use Docker for your application. So today I create my application, say on a Windows environment. I need to make it ready for production environment. For that, I create a file which is called as a Docker file. Docker file, you can just assume it is a type of recipe book where you provide all the ingredients used to cook a particular item. Same way you're cooking your application. So basically, you configure all the dependencies, libraries required for your application in a file called as Docker file. This Docker file is then run and an Docker image is built from the Docker file. Docker understands Docker images. Now, if you are from the Java background, we have classes. Classes are specifications. Same way, Docker image is nothing but specifications for your applications. Once the Docker image is created, this Docker image is then run on an instance of a container. So containers, you can assume they are objects of Java classes. You can create multiple containers from one Docker image that is nothing but your application specification. Now this container can be run locally on your local machine. Alternatively, once the Docker image is created, this Docker image can also be hosted on the Docker Hub. Again, you have to register on the Docker Hub, create a login, and then you will push your Docker images on Docker Hub. You can either have it a public repository or it can be as well a private repository. So it allows you to provide both the options, whether you want to make it public or you want to keep it private. So Docker Hub is nothing but repository of your images. Now once your image is pushed on a Docker Hub, it can be pulled and pushed by the integration testing environment, by the staging environment, production environment, development environment, anywhere. So it just becomes easy once an image is created, pushed onto the Docker Hub, and in any environment you want to run the application, they can be pulled from the Docker Hub. Alternatively, if you are working with a serverless environment, that is loading your applications on the cloud, the cloud environment can also pull images from the same Docker Hub. So this is basically the workflow of a Docker application, or maybe you can say Dockerizing your application or creating a Dockerized application. Definitely, Docker, again, it's a tool, a deployment tool for deploying your applications, irrespective of the platform you are working on. It has an architecture. It follows a client-server architecture. There is a Docker client which talks to the Docker daemon. Daemon is nothing but like a server, a thread running in the background, which does all the heavy processing for you for building, running, and distributing your Docker containers. This daemon can be on the same system, or definitely it can be running remotely as well. They both communicate either via using over a REST API, Unix socket, or a network interface. Docker usually works on the TCP/IP protocol. Once you understand the Docker architecture, that means it has components like client. It has various commands like build for building your Docker image, pull for pulling the Docker image from the repository, run for running your Docker image to start the application. When the client, that is, you can give the commands from the CLI, that is terminal or command line interface. Once you give the commands, the Docker daemon looks up for the images if they are cached. If not, it goes to the registry, picks up the corresponding image specified in the Docker file specifications, pulls that image, and then creates a container for your image. Alternatively, if your image is cached locally, it will not make a trip to the registry. It will just look up in the cache, and if it is there, it pulls up from the cache and starts the container for that image. Now, these were all the components, terminologies used in a Docker environment. Let's see how to install Docker, verify whether Docker is installed properly or not, and also run first Hello World program, which is provided by the Docker official website. So we'll go on to the link, that is docs.docker.com, and install. Once you go on to this website, you can see you have options of installing the Docker Community Edition. If it's Mac, select Mac. You can say download from Docker store, and once you are redirected to a website, you definitely have to create a login. So I am already logged into the Docker Hub, and then you can say get Docker. Once the Docker is downloaded and installed, and if it is up and running, you would see the icon on the top. You can see Docker is running. Once your Docker is running up and started, you can test for if the Docker was installed successfully or not. Open your terminal for checking the Docker installation. -v. You can see it displays the version, and that means your Docker is installed successfully. Alternatively, you can also say Docker -help. And once you do this, you would be given a list of Docker commands along with the description of what those commands do. We will be using few of the commands in the upcoming sessions of the Docker. Then I can also run the first Hello World program. So for that, for running, I'll say Docker run Hello World. Once you do this, you can see Hello from Docker. It also shows you the list of installation. Because in my case, I already have a Docker image, it doesn't go to the repository. If you are running it for the first time, you will be getting a message unable to load the image, and it goes online downloads the image, and then it runs the image. So see, it contacted the Docker daemon. It looked up for the Hello World image from the Docker hub. It created a new container, and then you can see it streamed that output to the Docker client. Okay, so you have all these options that you can do with the Docker command.